Okay, hi again. Oh, this I think this may be louder. Okay, all right. Hi again. So we are back with completing the square parts 2 and 3. So will be part 3 of the completing the square, the final part of completing the square. For EMaths. Okay, for EMaths. Yes. So what is the final part? Okay. Yes. Here we are solving equations with completing the square. So previously we just changed the expression from a general form to our completed square form or our vertex form. Here in part three, we are solving equations with completing. So we are solving the equation itself. Okay. So here we go. All right. So once again, previously, all this that we are doing over here, these are expressions, right? All these things are expressions. So what are expressions? They are mathematical phrases. They are so-called incomplete sentences, phrases only. So what do we do is that as we go, we need to maintain that equivalence from one to another. We cannot like multiply two throughout. We cannot minus one throughout, that kind of thing, because it has only one side. It's only an expression. So whatever that we do, we need to balance it within the same step. Okay. But this we are moving on from expression, right? Expressing from this to completed square form, general form to completed square form, and we are moving forward to an equation, a mathematical sentence itself, right? So on our equation, as you can see in our practice now, practice now what ah? Practice now 5. Okay, practice now 5. Okay. So here. Okay, let's look at practice now 5. Okay, page 8. Here we are solving equation already. Okay, so the skill over here is not expression, alright, is solving the equation. Okay, so how do we solve equation, right? Using completing the square. So there are two ways in which you can do this. I'm just going to write down the first question here. Okay, all right. So what do we do is when you complete the square, the key step is to add b over 2 square minus b over 2 square on the same side. Remember for our expression? Okay, we did that um for expressions. So for equation, right? How do we keep the balance for equation? For equations, we have two sides. We have the left hand side, we have the right hand side. So technically speaking, we just need to balance both sides and we can complete the square. Okay, but however, if it's impossible to do so, then we can do all at one of the side. So the first method is our traditional method. We can mark, right? We will squeeze in the b over 2 squares on the left hand side. So we need to add our b over 2. So b is 6. 6 over 2 is 3. So plus a 6 positive 3 square minus positive 3 square. And we will minus 4 and we will be equals to 0. So this one is to maintain the equation, right? So then complete the square for the first three terms. First three terms, shrink down them into a nice square. So x plus 3 square. Negative of 3 square would be negative 9 minus 4. Okay, then simplify. So we have our x plus 3 square minus 13 equals to 0. So now we are going to solve the equation. Do we need to expand back the whole thing? Don't have to, because you can see that actually this is there's only one x now. Previously we have an x square, we have a 6x. A bit difficult to throw and do the usual algebraic manipulation. But now we shrink it up, we completed the square, we are only left with 1x. So what do we do? It's something like changing the subject. Just throw everything, take off the shoe, take off the clothes, this and that, okay? So the 13, move to the other side. We have a x plus 3 square is equals to 13, okay? 13. Then square root x plus 3 is equals to plus or minus square root of 13. Okay, then our x is equals to plus 3, move to the other side, minus 3 plus root 13 or minus root 13, either one. So in your calculator, because this is our exact form. So in EMath, we want exact form, we want this. In EMath, we want 3SF. So because we don't use the surd notation here, so the square root notation over here. So we need to express in 3SF. So negative 3, we do the plus root 13 first. We get our 0.606. Okay, then the minus 1, negative 3 minus root 13, negative 6.61. Okay, so these are our two answers in 3SF. And you can observe, right, that when we do such things, our answer is actually not an integer. Okay, our answer over here is not an integer. It is not a whole number. It is very long, not exact. Why? Okay, because if you realize, right, from the equation on top, x squared plus 6x minus 4, can you factorize? Right, the question is, can you factorize this equation nicely? We can't. Okay, we cannot factorize nicely, so that's why we have such roots. Okay, we cannot factorize to integers. Okay, so that's why we learn completing the square, so that we can solve equations that we cannot factorize. Okay, so this is the first purpose of learning our completing the square. Okay, now let's look at 1b, y squared plus 7y plus 5. Can we factorize it nicely? 5, we get 1 and 5. The most we get is 1 and we get 4 or 6, right? So we can't get a 7. So if we cannot factorize, how do we do this? We complete the square, right? So let's go with 1b. 1b, let me okay, 1b, we have y squared plus 7y plus 5. Okay, all right, can so here we can't factorize, so we have to use completing the square. So same thing, we can complete the square, but now I'm going to show you a second method. Okay, so I'm going to show you the method 2. Previously was method 1. Okay, previously this one was method 1. Okay, now I'm going to show you method 2, right? Same completing the square, but we'll do it slightly differently. Okay, so what we are doing is actually, because we're dealing with equations, so that's why we can do this. Okay, so here I'm going to move the 5 to the right because I just want to complete the square for that two terms. So I'll move that over first. So I have my y squared plus 7y. I keep a gap here, so I'll tell you why later. Okay, oh wait, might as well. Okay, alright, move the 5 over, negative 5. Then I want to complete the square for that thing on the left. So what I do is, okay, this is a plus 7. So the ingredient is my b over 2, right? So I need to add a positive 7 over 2 square on the left. Okay? Now at the same time, in order to balance the left hand side, I need to balance on the right hand side. So I do the same thing on the right hand side. I need to add a 7 over 2 square. So if you were to compare this and the previous example we add and minus on the same side. Now this one I'm adding on both sides. They are actually the same thing, because if you carry the negative 1 over, they are both plus, correct? On both sides. So for solving equations, because you have two sides, you can do this. Okay, then we complete the square for the left hand side. For the left hand side, we have a y plus 7 over 2 square, right, on the left. On the right, just use calculator. So negative 5 plus 7 square over 2 square, 29 over 4, right? Like that. Oh, just nice. Okay, then we will solve as usual. Remove the outer thing, remove the outer function, remove the inner thing, then we find our answer. So remove the square first. So y plus 7 over 2 this is our plus and minus square root of 29 over 4. Okay, then we bring the 7 over 2 over, so we have a negative 7 over 2 plus root 29 over 4 or minus a root 29 over 4. Okay, then we key in our calculator. Okay, so we express the exact form first because we may need this some other day. Make it a habit first, then we use calculator. Okay, so we have a negative 7 over 2 plus root 29 over 4. Okay, here negative 0.807. Okay, second answer is the one with the minus, so I will have a negative 6.19, okay, in 3SF. Okay, so the difference for method 2 and method 1, right, is that method 1 I complete the square, I do the steps on the same side, so I need to add and minus. For method 2, I add on both sides so that it's balanced. So if you do both on the left, it's balanced there. If you do on both sides, it's also balanced on both sides, so nothing changes. Okay, so this is how we do it for method 1, method 2. So only these two methods. Pick one, we follow. For me, I would follow method 1, okay, to keep it consistent to my expression, the previous few concepts. So for C, I'm going to use method 1 again, alright? So for C, okay, for C, I have my z square minus the z minus 1 equals to 0. Okay, so can we factorize this? I don't think so. 1, 1, 1, you get 0 or 2, but this is negative 1, cannot. So we have to complete the square. So I have my z square minus z, I have my minus 1 over here. I'm going to add a b over 2. So b is negative 1. Negative 1 over 2. So I'm going to add a negative half square. Move this over here. Move this over here. So I'm going to add in a negative half square. I'm going to subtract a negative half square over there. Okay. Then complete the square for my first three terms. We have my z minus half square. Then I simplify those on the right. So it's a minus negative half square minus 1. So minus 5 over 4. Okay. So the last two terms, I simplify those last two terms. So I complete the square for these three. Okay. And I simplify this one over here to 5 over 4. Okay, so I'm just doing a few steps at one go lah, huh? So here I bring the 5 over 4 to the other side. Okay, then I remove one by one. So z minus half is equals to plus minus square root of 5 over 4. Remember, when you take the square roots, when you reverse the square, you need to have both plus and minus values. Okay, then we have our z is equals to half plus minus of this. Okay, so write this down in 3SF. So we have half plus root 5 over 4, 1.62. Then if we minus, we have z negative 0.618. Okay, 3SF. Okay, so there goes our solving the equation. Alright, now for question 2, they give us in factorized form, meaning already factorized but equals to 15, but we can only split it out and do that this or that, right, when the right hand side is 0. So unfortunately we will need to express this in general form first. Okay, so for question 2, okay, so x plus 4, x minus 3 is equals to 15. So we can't just do this equals to 15, that equals to 15, because 15 are made up of different factors. Like it can be 1, 15, 3, 5, and so we don't know which is which. So we just expand nicely first. So when we expand, we have our x squared minus 3x plus 4x minus 12 is equals to 15, right? Bring all to the left, so I have my x squared minus x minus 12 minus 15 minus 27. Okay, I will simplify to this. Okay, then 27, 1, 27, 9, 3. We cannot get the 1, so we can't factorize. How? We complete the square instead. So I will have my x squared minus x. Then the b is negative 1. I'm going to add my b over 2. Negative 1 over 2. Okay, and I'm going to minus away my b over 2. Right? And I have my minus 27 over here. Okay, so move this over so that you can see nicely. Okay, then complete the square for the first three terms. So this one, we complete the square. Okay, so here we have our x minus half square. Okay, and this one on this side, we will simplify with the calculator. So minus negative half square minus 27, ayo, 1 minus 109 over 4. Okay, so we've got this down. Okay, solve one by one. So move this to the other side. So we have this 109 over 4. Remove the square. So we have a plus minus square root of 109 over 4. Move the half to the right. Half plus minus root 109 over 4. Then we have our plus minus. Okay, so half plus square root of 109 divided by 4. Okay, 5.72. Or okay, so negative 4.72. Okay, 3SF. Okay, now so for this one we solve the equation. So now some of you may ask, can I use alternative methods? Can I use, you've learned the formula later, but can you use the formula to do this? Unless it is specified, you can use any method possible. But for the sake of practice, for now, for these few questions that you are writing down, at least do completing the squares, okay? And for at least that worksheet, do completing the square, because unless it is specified, they may want the way they phrase the question, they may want you to show the completing the square. So if it's specified, follow. If it's not specified, any method possible. Okay, so this ends our completing the square series for EMaths. When we see you in school, we will continue on with quadratic formula, the third way of solving quadratic equation. Alright, see you soon. Bye.